Hey there, welcome back to the channel. My realloc code is mostly done, and now the errors remain. Okay, I will easily fix this, so not a big issue. Boom, oh, sorry. Boom, boom, boom. Yep, it's done. It should compile now, and but it won't run. As you can see, the code is not present. If someone doesn't know, we should. So this is the results of libc malloc. But we should get our results too. But as you can see, there is a segmentation fault. So we'll fix this. So let's get started. I have to go through the entire realloc code, like what is it doing, because that's where the error is occurring. It's about this much. Like we have to just go through 77 lines of code. So not a big deal. Let's get started. So void my realloc. So first we get a size, and then we have to align size, definitely. The block, which is the current pointer is, oh, I get it. I get it. This was easy. This was rather like very easy. Did it compile? Oh, it's done. What? Seriously? Yeah, this is fine. I'll fix that later on. I was going to make a bigger video. Damn. Wait, is it really working though? Wait. So this is the util. Okay, that is sus. That is sus. What? Why is my utilization 1000%? I guess this is related to throughput. Look at this. Oh boy. Why is it 107%? Oh. Why is it 1000%? What? Wait. Okay. So if I comment this, and if I oh sorry, and if I uncomment this, so this is the old realloc. And if I make and m driver dash v, yep, okay. So the values like 71, 88, 16, okay, 71, 88, 69, 71, 88, 69, 99. I guess only trace file number 9 is calling realloc. Let's test that. So nvim traces. Yeah, I'm very okay. Yeah, it does have the realux, but I'm not sure whether 8 has them. Okay, 8 doesn't have it. Wait, I will just open this as traces. How about that? Inside 2, no. Inside 3, no. Inside 4, no. Oh, sorry. Inside 5, no. Inside 6, 7, 8, nothing. There's 9. We have a lot of the realux in number 9. Damn, I was really happy about the score, but now I'm sus. I need to make sure. This shouldn't be this like shouldn't be 1000% at all, right? It's just theoretically not possible. Wait, I need to make sure. So is it compared to is the utilization compared to this? Like is it compared to is it is this a comparison to well, it's not a comparison. Let's check. Let's check. Okay. This is going to be a very short video if I'm able to get this right. Oh, sorry. Okay. RG util, it should be inside mDriver. Yeah, perfect. And yep, this is. So let's find how are they calculating util. So inside mDriver, let's take a look. mDriver.c. What is this? Piece utilization for this tray is always zero for libc. Why though? Sex and util are only defined if valid is true. Okay. So routines for evaluating correctness, space utilization, and speed. Yeah. Okay. So this is the function eval util. Okay. Eval util. It's oh yeah. Okay. So let's take a look. So yep. Eval speed is fine. I don't think there is anything that I want to know about it. So this yeah eval util. This is it. So evaluate space utilization of the student's package. The idea is to remember the high watermark HWM of the heap for an optimal allocator, that is no gaps, no internal fragmentation. Utilization is the ratio HWM divided by heap size, where heap size is the size of the heap in bytes after running the student's malloc package on the trace. Okay, so high watermark HWM of the heap for an optimal, there's no gaps and no internal fragmentation. Okay. HWM of the heap. Yeah, let me just make sure that HWM heap watermark. What does that mean? How high watermark is the highest value point reached and okay, I don't understand that, but okay. It's divided by heap size. If we are getting 1000%, that means our heap size in that so our heap size for that specific trace file is where is it? Yeah, let's open it over here. So for that, I guess this is the file. Wait, yeah. So 4801 is the what you can say. So 4801 is the the size allocated you can say. The 100. What does the 100 mean? I don't remember. What does the 100 mean? Wait, does this get lower anytime soon? It doesn't. Hmm. What does the 100 mean? I don't remember. Yeah, it's fine. Let's keep looking. So mm initialize the heap and malloc package. Memory set brk. This is fine. Trace number of operations. So this will run 10 times. Yeah, this is the type, case, alloc, realloc, implementation, realloc, old, new size. Okay, break, max total size. So it does a bunch of things. So in case of alloc, there's index, there's size, sure, trace, block index equal to p, remember region and size, yeah, sure. Total size plus equal size, keep track of the current and total size of all allocated blocks. Okay. Max total size is equal to total size greater than max total size. If it's true, it's total size. If not, max total size. Yeah, sure, break. Okay, so it's keeping a track of the total size. This might, yeah, this is doing the same thing. In case of free, it reduces. Sure, case right break default. Yeah. Max total size, same thing. Max total size is greater than memory allowance, and memory allowance is, I think it is depend. I think it is 50 MB. Oh, it's 40 KB. My bad. There must be something else. Yeah. Okay. So 40 KB heap size is equal to mem heap size. Sure. If it is exceeded, then this and return max total size. So the maximum total size that was present at a moment divided by heap size. And the heap size, where do we get it from? So we get the heap size from mem heap size, which is inside memlib.c mem heap size. Where, sorry, mem heap size is mem brk minus mem start brk, which is the maximum heap allocation achieved. So that must be pretty big because we went up to, okay, so that must be pretty big. And max total size, the max total size that we achieved. Let me just write, let me just add a print statement over here. So max total size. What is it? Is it a size t value? What is it? Yeah, it's a size t value. So percentage value, boom, 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 boom. Heap size, boom, 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 boom. Yeah, let's do it. Max total size if we are unsigned long. Oh, it's unsigned long. Okay. But max total size was supposed to be, oh, okay. Let's cast it. Sorry. Mm, yeah, let's cast it. It's fine. Wait, it's unsigned long, right? Wait, what is unsigned long? Long. What is unsigned? Wait, wait, wait. Uh, what is it? Printf formatting for unsigned long. I've never used it, you know. Hey, fine, I'm going to use this. LU, yeah, sure. It should have been UL, bro. It's percentage D. Okay, bro. And V. Yeah, okay. So max total size here went 22852 and heap size was 322192. Okay, sure. So the value over like the value that we get is, let's say, printf boom. What is for double? It's a F. Oh, it's the float, the same thing. Okay, so sorry. Let's do double answer equal to the same thing inside this. So we boom yank boom 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 paste uh, capital find equal to boom 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 boom. Did I make it though? Oh yeah, sorry, my bad. 70, this. Then why did we get. Okay, sorry, my bad. I forgot to. Yeah, let's comment this one out again and uncomment this. Yeah, that's cool. So let's see it. What is the reason for this? Okay. Yep, this is the value. So the max total size that we reached was 615040, which is because of this. 615070 must be 615070. Yeah, it's not valid. But it is because of this. That is the maximum allocation. Max total size that we reached was 615040. But it should be freed, right? Wait. Uh, M driver dash C. This is the one. See, max student size that. Oh no. So remember. So bad headers over here. Size. This is garbage. This is garbage. Oh, okay. I think I need to fix this. It's still not done. But yeah, I was very happy to see the like thing. Of course, 100%, 107% utilization. That is, yeah, sure. Like it's possible. But, so max total size went that, and that is because. So when are we taking after 10 iterations, right? After 10 iterations, 615040 was present. So here at this position, if I call what should I call it? The check function, right? What is it called? My check. Yeah, my check. Yeah, let's call my check at this position. So yeah, checking stuff. My check. It's a void, right? Yeah. Oh no, it's end. It returns a integer. Yeah, yeah. Who cares? So yeah, just call it. And print statement boom. So yeah, you forgot to make, yeah. So this is, yep, this is when it's called. So this is for the first one. I should add a print statement above it. Okay. So print statement above it. My check for the first one. Sure. 87%. Where is it? 87, 88, whatever. Same thing. 87.4. This is the check for the second one. So whatever the check is, we have to check the above value. So this is for the second one. No, sorry. Yeah, this is for the below one. So yeah, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is for the ninth one. So one below that, this is the one, and this is 614792 at the end of every execution, and it's done. 614792, 614792. Four extra bytes more than this. This needs to be, so I need to fix this. So it's not over. Oh boy, it's not over. Yep, it's fine. I was very happy to see the. Uh, yep, I thought I was a genius. Like, bro, I'm 99% better than glibc by using a simple free list, bro. So now my action should be to find why my yeah. So let me show you. So this is m driver dash c. So yeah, let me remove the print statements. I know what is happening. Uh, get status. Yeah. Uh, let's restore it. So get restore m driver dot c. Yeah, sure. M driver dash c. So this is what is happening. So even if the first trace file is ending, it checks at the end of the execution that if there is, any kind of block that needs to be freed up, that has not been freed up yet. So this is the 32 bytes that is present, but it's not freed. Sorry. And then this is a 2056 block. This is a 120, 80, 2168, 48, some garbage, 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 98, which is not possible. So I have to check like what is causing this to be not freed. You getting me? So first thing in my mind was because of like uh garbage free allocators. So sorry, garbage free blocks, which is like some blocks that remain just because of header plus footer, which can be uh, satisfied by like this theory can be satisfied using like 32. See, 32, it's a multiple of 32. I don't think 2046 is a multiple of 32. Let me check though. But 48 definitely isn't a multiple of 32. So yeah, that theory falls on its face. So what is the reason that the space has been allocated, but trace file 9, right? How about we add something? So here we have the final return statement, right? So Sorry. Yeah, let's try something. So I have to check what does the free list look like at the end of each execution after. Hmm. Then let's try to add that. Let's do that. Let's do it at the end of my malloc. About that. Sorry. Let's add one over here. So this is a void pointer, not void pointer. I have to just call traversing. So there's no need of calling traversing at this point because it's just a traversing. The traversing we shouldn't be so what I did was we shouldn't be calling traversing inside this function at all because of this function nothing happens. The block remains the same. The free list remains the same. Sorry. So yeah, calling traversing over here and then inside I'll call one inside the myFree function. Yeah. So here we don't have any return statements, but let's just call it at the end. So traversing three pointer, sure. And now inside coalescing. So one is present over here. So let's call it. This is split block right here. So three pointer, one over here. No need of that. It remains the same. And one over here. Traversing three pointer. Okay, so that's cool. And let's add some statements for us to be able to easily identify. So the alert percentage schedule. Let's not do that. Oh, let's do that. So printf ZU. Sorry, realert ZU. Boom boom boom. Boom boom boom. Okay. Printf alert percentage ZU. Boom boom boom. Boom 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 boom. Okay. Let's take a look what it looks like. We should run only the trace file. Let's not do that. So only the ninth trace file should be run. So driver dash f traces trace number 9. This might take a bunch of time. My CPU must be screaming right now. Yep, it is. But it's fine. I think we can handle that. This should be pulling in. Yeah, okay. This might take a lot of time, I guess. Yeah, it's fine. I wanted to check like what kind of power does my laptop possess. Let's try that. It's still going. That's cool. How about we only call it when we are reallocating? Yeah, how about that? That sounds better. Let's add one more condition over here, which is if size is equals, what was it? 614784. Yeah, 61 614784. 614784. Um, how about that? It's pointing to itself. It's pointing to itself. Sorry. Okay, let's add that. So, if size is equal to 614784, then traversing three pointer. How about that? Let's take a look. If it's done, it's the same thing. It's pointing to itself. For some reason, it's pointing to itself. And for some reason, it's terminating. Let's get this output inside something. So, this is what it saw. What is causing this? Let's push it though. 36 minutes in. Should we end this right now? The block isn't getting freed. Who's causing it to stay though? Hmm. At what point should I say, in my knowledge, in my knowledge, the space that's left over here, which is, let's say, this one, like, this happens only and only when this is 30 in hex. Sorry, man. Um, Hex to decimal. This has to be at least, what is it? So 18 is supposed to be 24 or 32 bytes, right? When I see 18. Yeah. So when it is 18, it's 24 bytes, yeah. And when it is 30, it is 48 bytes. Hmm. So my marker was found at 48 bytes, which is, sorry, 30, 30, the same thing. Yeah, let's take a look. So nvim trace file, trace one, and the last block which is fade is 11769. 11769 is 32 bytes. So this is what it is trying to read. Am I sure about that? No. Let's test our theory. So the last block which is freed is 2399. It was allocated 11699 bytes. If it doesn't hold true. For the third one, it is 2056. Oh, okay. So there is a C0 that I didn't think about. So the last byte to get freed is 999, which is a 4072. But let's search for 48. Let's start from the bottom. Let's start from the top. About to allocate 48. So this is the only 48 block. Oh my bad. This is supposed to be A and then slash D, any kind of number. How do we do that? Right? What is it? Ah, the forward one, I guess. So 48 is the 2 and 220 block. So 220 was freed. Pretty quickly. Yeah, this was done also quickly. Then what is causing you to have 32? Like, what is causing this to be stuck at 30? Let's check out the function. Check. So this has a char pointer b, a low and a high. The size is 0. So b is taken as low, and while low is less than or equal to b and b is less than high. So p is greater than or equal to low and p is less than high. P is low, so this is low, the start, right? So mem heap low gives us the start of the heap, which is that char pointer, that address. P is taken as low. Okay, so yeah, low, mem heap low, and mem heap high plus one because it is one byte less. Sure. And we have size value P is taken as low, and while P is greater than or equal to low, which will be the start. It will it will keep increasing by size to size. Okay, what is the use of this? So we are setting the size value as this, which is size value at that position. Okay, checks are invariant that the size t header before every block points to either the beginning of the next block or the end of the. We shouldn't even consider this. This is for the earlier diagram. Oh boy. Let's end the video. I don't think I will be able to think for long. The first few minutes were great, but yeah, let's end the video right now. 1000%. No, no, 1500%. Wow, that's fine. I'll debug it. Yeah, we'll find the reason for it, or maybe I'm a genius. You don't know. Yeah, fine. Let's end it. So, the journey, and I will see you fun. Bye.